Assalamualaikum warahmatullahi wabarakatuh. Hi, I'm Dr. Rozaine again. So today I would like to give one example about this clutch. Alright, the question is like this. This clutch that has both sides effective and outside diameter 4 times the inside diameter, used in an application where 40 kilowatt is to be developed at 500 rpm. Determine based on uniform pressure condition. First, the inside and outside diameters. Second, the actuating force required. And the design decisions, friction material with the coefficient of friction F equal to 0.25, and the maximum pressure is 20 kilopascal is used. Right. So in order to solve, from the question is given to us the outside diameter, which is large D equal to 4 small diameter. So D equal to 4 times small d. So this is the first equation, and then from the question also mentioned about the power. So from equation of a power, we have a P equal to T times omega, right? So the T times the omega is 2 pi n over 60, right? Because in the equation given to us, n is in rpm. So we substitute all the information. So we have a power 40 kilowatt equal to T, which we would like to determine, and then 2 pi, n is 500 rpm divided by 60, and then we get a value of T, which is a torque. And then by using a uniform pressure as mentioned in the question, so we use the formula for the uniform pressure. So torque T equal to pi F P max over 12 times outside diameter power of 3 minus small diameter power of 3. So since both sides effective, meaning that the number of active friction surfaces, or N, is equal to 2. Okay, so N is number of active friction surfaces. Okay, right. So we just substitute all the values, but please bear in mind that this torque value must multiply with number of active friction surfaces, or N. So we substitute all the values. So T we get from the equation that or the value that we obtained before. Alright, so we just substitute over here, and then a pi. F is coefficient of friction, and then P max is 20 kilopascal divided by 12, and then a big D cube minus small d cube, right? And times 2. Okay, right. So this is the second equation. So so first equation, we substitute in equation number 2. So the first equation is outside diameter equal to 4 times small diameter, or inside diameter. Right. So so this is the torque value, and then applied 0.25 times 20 exponential 3 by 12, and then this is the first equation, which is we substitute the big D to the small d. So small d is 4d, the power of 3. Okay, and then minus d power of 3 times 2, and then after we have solve the equation, so we get the value of D. And then we know that the outside diameter is equal to 4 times the small diameter or inside diameter, so we get an diameter of outside diameter D. Okay, the second equation, the second question is actuating force. So Fa equal to 1 over 4 pi P max times big D squared minus small d squared. Alright, so we just substitute all the values. So 1 over 4 pi 20 kilopascal. So the outside diameter is we already determined here, so we just substitute over here. And similarly for the small diameter D, we just substitute here. Don't forget to square the values, right? And then lastly we get a value of actuating force in Newton. Okay, so I think that's the solution for the this question.